Hello, and welcome to your next round of videos. This chapter is all about logic. Now, logic is one of my favorite topics. We'll see if you share that enthusiasm. But today's chapter is going to be an introduction to logic. We're going to go over some of the basic concepts so that you can get, logic is probably going to be very new for a lot of you. This is not your typical algebra. And so today we're going to go over some definitions, also how to set up symbols and statements and look at true and what makes things false. But we're going to be looking at, so with logic, we're looking at, let's just get actually into my first definition here, which is a statement. It's a declarative sentence that is either true or false. It can't be both simultaneously, meaning when we're working with logic, we're going to be working with statements that we can definitively say whether they are true or false. Then we have connectives. These are words or used to connect thoughts. So in a little bit, this is kind of like an English lesson, but then we'll get into more of the symbolic form. If you think about when you combine sentences, we can use connectives such as and, or, if, those types of words. We have compound statements. These are sentences that are consisting of two or more simple statements joined by a connective. For example, the dog went out would be a statement. Drank his water. The dog drank his water. That's another statement. It becomes a compound statement when we put it together with the word and. The dog went out and drank his water. That's automatically now a compound statement. But we also have words for ands and or, and we call the and statement a conjunction. And what we're going to be doing with logic, and if you remember back a few videos when we were working with, we were looking at measurement and conversion, we were looking at the very first chapter on critical thinking, we brought up symbols such as the P and the Q, where we changed a sentence and we said, well, this sentence will represent P, this sentence will represent Q. This is what we're going to be doing in logic. When we're working with a compound statement, each single statement would be given a letter, such as P, Q, and then we keep going, R, we can do S. And when we put sentences together, because what we're going to do in this chapter is we're going to turn all of these sentences into symbols. And when we do that, every statement will get a symbol of a P, Q, like I said, R or S. If the word is and, then the symbol is this symbol right here. Kind of looks like the caret key. That represents the word and. So if we had P and Q were simple statements and we had them put together with the and, like the dog went out, that would be the P. Drank his water, we would say that represents Q, and that would be that symbol. And so we would write it as you see here, P and Q, and that's how we would say it, P and Q. We will also be using the or statement. In that case, it looks like a V or the upside down and symbol. And again, if we had the word or, we would still have our statements being P and Q. Those are your symbol statements, but then the disjunction would be using that symbol, and we would say P or Q. So we have P and Q, P or Q. Negation. Well, this basically means the opposite in meaning. So if a statement is true, then the negation would be false, and vice versa. So if the statement was false, and we said we want the negation of that, then it would be true. So in other words, negation means opposite of what you found. We use this symbol right here. It's kind of like a squiggly line, but that means negation. So if P is a statement, the negation would read, you have the symbol, the negation symbol with P. The way we say that, and I have it here, is we say not P. If I had it in front of the Q, we would say not Q. So that's how we would say it when we're reading these with symbols. Let me see if I can slide this up a little more. Let's go to the discussion, just to kind of show you different ways we can do this, how we would write this out. P, it's telling us, is the temperature is 80 degrees. Q is going to represent the statement the AC is not working. R represents the apartment is warm. So here are your symbols, and these are the statements that they represent. This is saying find P and R. In other words, what would P and R be written out as a sentence? Well, it says P, that would be, and I'm going to abbreviate so I don't have to write so much. That would be the temperature is 80 degrees, and yes, I'm just going to use that symbol. And, because that's the and key, remember, the and symbol, the apartment is warm. That's how we would write that out using those symbols. In other words, what do these symbols mean? They represent this. Let's try B. Not P and R. So I'm just going to edit the first one so we can do less writing. This would mean that the temperature is not 80 degrees. So because of the negation, that's how I would write this. It's very similar to A, except I'm going to add the temperature is not 80 degrees and the apartment is warm. Let's go to the C. Q, and that's your V, so that's your R, or sorry, or, Q or R. Q represents the AC is not working, or the apartment is warm. That would be that sentence. This one had the and. With the second part, we added the not. This is just your P or your Q or R. Now, with the next one, this one, let me just show you it's a little different. With parentheses, this lets me know that when I write this out symbolically, I'm going to put a comma at the end of the parentheses. And let me show you what I mean. P and Q, that would be the temperature is 80 degrees and the AC is not working. Comma, or the apartment is warm. I put a comma here because that would indicate, if we were going the other way, that these two would be in the parentheses. And then it would be that. Depending on where the parentheses is, that's going to tell you where you would put the comma. All right, let's try another one. This one, okay. Here's what happens when you have the negation in front of the parentheses. This part will still be the same, the way we would write this. But this says, it is not true that, or it is false that, whichever one. And then we're going to do Q, which was the AC is, and in this case, notice what Q was. The AC is not working. Okay, well, I want not Q. That means the AC is working. Remember, we make it the opposite. And R, which is the apartment is warm. So the negation in front of the negation just means that we're going to say it is not true that, or it is false that. And then the rest of this, you would just say it how we were talking about. Now we're going to go the other way. Now we're going to write in symbolic form. Here we have the temperature is 80 degrees and the AC is not working. Now, just as a reminder, we'll go back up here. The temperature is 80 degrees as your P, and Q is that the AC is not working. All right? So I have the temperature is 80 degrees and the AC is not working. That's your P and Q. Now let's do the next one. The AC is working, or the temperature is 80 degrees. Well, the AC is working is our Q, or the temperature is 80 degrees, that's your P. So we just basically wrote it the opposite way. The last one, the apartment is not warm, comma, and the AC is working or the temperature is 80 degrees. Here's that comma. This is what I was talking about. Let me just kind of highlight that in red real quick. Right here, that tells me that the rest of this will be in parentheses. Wherever I see the comma, if there was a compound statement before that, I would put it in parentheses. But the compound statement is after that. That tells me it's these two that will be in parentheses. So let me show you. The apartment is not warm. That would be not R. And the AC, so now I'm going to do my parentheses. The AC is working. That would be not Q, because remember, Q was not working. Or the temperature is 80 degrees. That's how we would write it. So that comma just lets me know where I need to look for the compound statement to put in parentheses. And then that means this single statement would be by itself. All right. Now logic, if this is very new to you, this could take a while to get used to. There's something else called a conditional statement. So we have the and, the or, and then we have the conditional. This is where there's a condition, meaning we're saying if this, then this, right? We symbolize it with that arrow. And the way we say it, you can see it right here, is we say if P, then Q. And we did mention this back in the critical thinking chapter. So at least that part's not as new. Look at this discussion. So we're going to say P means you are distracted, and Q is it is difficult to study. How would we write out if P, then Q? Well, we would say if P. So you are distracted, then Q. It is difficult to study. That's how we would write that out in words using our symbols. So this is, like I said, this video is a lot of your introductory to logic. So you get a whole lot of new terms thrown at you, but you're welcome to go back and watch the video again or watch certain parts where you might seem confused on different areas. Last but not least, and we're going to work with quantifiers more towards the end of this chapter, so it'll be one of the last videos. But just to give you an introduction, because this is where you're getting all of the new terminology, quantifiers are where we're using the words all, none, some, each, every. These are different than your typical and, or, and the P, if P, then Q. I want to show you just real quick. This is a little chart I always make in class, but the words that you'll be using mostly are all are, and there's a reason I'm writing it this way, so follow me. Some are, none are. Another way to look at that would be no, right? And then some are not. Now, like I said, there's a reason why I'm writing this. These are opposites on the diagonal. The opposite, okay, the negation of no or none are would be some are. That is the negation. The negation of these two. So this is the chart I always use. The negation of all is actually some are not. Because I've had students who in the past will say, well, the opposite of all are none. It's actually not. The opposite of all is actually that some are not. And the opposite of some are not is all are. Same thing here. The opposite of some are would be that none are. So let's go back over here now to find negations of these. So we have all are red. So I go to my chart and use this chart. I've used this forever. I go down and I see some are not, and that would be my negation. So some are not red. That's my negation. None are blue. Well, none, the opposite is some are blue. What I usually joke on this because sometimes you don't want to use your own logic because it might not work. All of us like popcorn. That means Some are not. How would I word that here? I might say, some of us do not like popcorn. So all of us like it, some of us do not like it. And then some computers have a 3-year warranty. Here's some. The opposite are no, none. So I would say no computers have I'll just do ... but a 3-year warranty. You can get my point. So no computers have a 3-year warranty.